Okay, everybody, good day. I am going to go over the isotopes worksheet a little bit with you. I've got a couple of slides on PowerPoint that are going to help us out. I just want to kind of walk through this a little bit to help you get it done. So first off, reminder about isotopes. Isotopes are atoms of the same element that have a different mass. So they have the same number of protons but a different number of neutrons. So we want to think about that. When we're looking at isotopes, one of the things we're going to talk about a lot is atomic mass. And we've talked about mass quite a bit already. One of the things I want to be clear about is when we've talked about mass, we have looked at it in a couple of different ways. And so atomic mass can mean a couple of different things. It can be the mass of a single atom. So when you have for example, a hydrogen atom that has one proton and one neutron, it has a mass number of 2, and that is the mass for that atom. You could also have a hydrogen atom that has one proton, and so then it has a mass number of 1. Or you can have a hydrogen atom that has a mass number of 3 because it has one proton and 2 neutrons. So that's one thing we can mean by atomic mass. The other thing we can mean by atomic mass is it can be the weighted average of all the isotopes of atoms of that element. So that number we see on the periodic table is an average of all of the different atomic masses that an atom can have. So let's take a look at this for a second. When we talk about hydrogen, we might talk about how hydrogen has a mass of 1, or a mass of 2, or a mass of 3. Or the other thing we might see is we might look at the periodic table and see it has a mass of 1.01. Now, that doesn't mean that it's got 1 proton and 0.01 neutrons. That means if we look at how much of each type of isotope exists, we can figure out the weighted average. So it's kind of a confusing formula, but here's the thing. You take the percentage and you multiply it by the mass number of that isotope. So 99% of hydrogen is hydrogen 1. So we do 99 times 1. 0.99% of hydrogen is hydrogen 2. So we do 0.99 times 2. 0.01% of hydrogen is hydrogen 3. So we do 0.01 times 3. When we multiply those all out and add them together, we get 101. And we divide the 101 by 100, and we get an average mass of 1.01. So this is the weighted average. This is the average atomic mass of hydrogen. And so all of the numbers on the periodic table, most of the numbers on the periodic table are like that. There are a few that are whole numbers you'll see on the periodic table. Usually you'll see them in parentheses. I'll just say now, as an advanced note, that's not because the average is that number. It's because most of the isotopes of that atom are unstable and they decay. And so that one in the parentheses is the most stable isotope, the one that will last the longest. All right, so thinking about this, thinking about our numbers on the periodic table. No, I want to finish this and then I'll go back to the slideshow. So thinking about when we look at, say, carbon, thinking about that number on the periodic table, is it going to be a whole number if it's an average? Is it going to be a decimal number? And what whole number is it closest to? I will tell you the whole number it is closest to is usually the whole number of the most common isotope of that atom. So, something to think about there. Pardon me. For looking at this problem here, one thing I wanted to remind you is about this atomic symbol notation. So let's flip back to my slideshow here and talk about atomic symbols. So when we see something like this, remember the number in the top left, in this case 32, is the mass number. And the mass number is the protons and the neutrons together. And in this case, when we're talking about mass, we're talking about the mass of a single atom of that isotope. The number in the bottom left, the 16, is the atomic number, and that is just the number of protons, right? The letter, or two letters, is the atomic symbol for the element. In this case, it's the letter S for sulfur. And if there's a number in the top right, that would be the charge. If there's no charge, if there's no number in the top right, then that means the atom is neutral. And think about what neutral means for the number of protons and the number of electrons. So if we're flipping back to this worksheet here, you're thinking about here, you're using these mass numbers here to compare the number of protons, electrons, neutrons, and mass of these three isotopes of sulfur. So think about that. When you're going through and doing this section, if you just want to write the name of the isotope, so like carbon 12 here, carbon 13, carbon 14, you can do that. If you're having trouble writing isotope notation and symbol notation, that can be pretty tough to do. I mean, honestly, I can't write this on a computer. I have to go into a separate program, draw it out, and then copy and paste it. So don't feel bad if you can't get something to do 4, 2, HE, like that. So think about that. Fill in the boxes, or just write down what would go where. Think about tin. Think about your isotopes you would write. This one might be a little tough. If you want to just write the mass number and then the symbol, that's an acceptable way to write isotopes, or write the name of it. Tin, like 173 or whatever you're going to write for the mass number. All right. I think that's about all I've got to say about this worksheet. I'm going to upload this. Hopefully this will help. I'll be working on getting a couple others up today, assuming my computer doesn't die on me again. And yeah, that's about it. Good luck with this worksheet.